Hello, and welcome to the Professor Podcast with Ruth and Claire. Each episode, we talk about a particular topic in the life of a professor. Ruth is a visiting professor at a large university in Ireland, and Claire is an associate professor at a primarily undergraduate university in Northern California. The purpose of our podcast is reflection, so we bring something we think is working and something we're working on to discuss.
Welcome to the Professor Podcast with Ruth and Claire. I'm Ruth.
And I'm Claire, and today we're talking about memorization for exams. But first, Ruth, how was your week?
My week was excellent. We kind of getting back into normal life a little bit after a very festive holiday period.
Oh, festive, how nice.
Yeah, I was telling you, I think that we took the girls to like a pantomime.
Oh, yes.
I've had a hard time explaining because people are like, wait, so you took them to the theatre? And you're like, no, it's not a theatre, because a pantomime is sort of like a very raucous kids' Christmas time play event thing. And it involves a lot of audience participation and singing. And it felt a bit like we went to a nightclub at 11 a.m, but it was super fun and I salute the performers because I don't know how anyone brings that kind of energy to anything, but it was very fun. So it was quite the experience. But how are you? How was your week?
Oh, I'm good. I've been thinking a lot. So here's Claire's metaphor of the week, which is pushing the rock down the hill. And you know, and anybody who's been listening to a bunch of our episodes knows that I was working really intentionally on this one paper for so long, and it was so hard, and I was working like it was my main thing. I was spending lots of time on it, and I was making like minuscule progress. I had like 3 paragraphs after months, you know? And then I was like, okay, forget that paper. And then at some point I thought of a different paper. And it was just the rock was rolling down the hill. In one day, I did like 10 times as much progress as I had in months on the other one. And then at some point I realized it was actually 2 papers, and I split it apart, and I've been working on it and really having a great time. I feel like a scientist doing cool things instead of like someone just like, I don't know, trying to push this rock up the hill and having it roll back at me all the time. So it's just, I'm just feeling really excited about the concept that if I really hate doing something, if something seems just not what I want to do, maybe there's a different rock I could push, and maybe I could actually try pushing. There's probably plenty of rocks, and some I could be pushing down hills instead of up hills, and we could be getting somewhere a lot faster. So it's a nice reminder about that.
It's just, I don't know. All of this feels like it boils down to like fundamentally not trusting ourselves. But it's so crazy because it's not like you didn't want to push the rock and you wanted to like binge a Netflix show, which is fine too. But like you wanted to go write another paper, it's fine. You know what I mean? But it's like the resistance of like, oh no, we can't let Claire off the leash because Lord knows what she'll do. And then you're like, oh, I'm going to go write these other papers and be a scientist. So it's crazy how... And then part of me still is like, I don't know, Claire, because how do you know when you just don't want to do something because you don't like... But yeah, we should just trust, like, you're not...
Give it a shot.
Right,
you know?
Right. And that's awesome anyway.
Yeah.
And I love... It's sort of simultaneously awesome and also very tragic that you're like, I feel like a scientist, as if, like, you don't normally. Do you know what I mean? You're like, wait, really? But, like, I totally know what you mean. Like,
yeah. I mean, it's just... I don't know. I just find it remarkable that on paper, it's the same kind of task, you know? I'm writing a paper versus I'm writing a different paper. But this paper, I've just been, whenever I'm working on it, I'm enjoying it. And I feel like I'm doing something useful, and I feel like I'm saying things I want to say, and I'm figuring things out, and I don't know, it just feels like, it feels like I'm a scientist, which of course I am, as opposed to the other one just felt like I was doing this painful task that needed to be done. And so anyway, I don't know, just really interesting to remember that there are lots of rocks, and if I look around for a different rock, there's probably a just as good rock that I could push down the hill rather than a rock I'm trying to push up the hill.
Right, because I wonder, like, what was it you thought was more worthwhile about the other paper? Or was it even the fact that you didn't want to do it made it worthwhile? You know what I mean? Because then it's like, well, then I have to do it kind of thing or something. But that's awesome. That's very cool.
It's push rocks down the hill.
Yeah, I love this because now you're going to bust out papers and have epiphanies. Like, it's all happening from this process.
You're right.
So, yeah. And that's the magic of the sabbatical, right? I know we covered that already, but it's like you kind of Because you don't get to spend that much time on things. And you can be like, well, I'm just really busy. That's why I'm not using it.
You're right, because I definitely thought that the reason I hadn't written the paper before sabbatical was that I didn't have time. But then when I had plenty of time and was dedicating to it, I was like, oh, actually, there's a fundamental issue here. And eventually, by putting down that paper and giving myself some time to think, I suddenly realized there was this other, I had already considered this other data set, but I thought that I didn't have enough to say something. But anyway, the point is, once I allowed myself to think more broadly, I suddenly saw a lot more things that would be interesting to write about, that I was excited to write about. Anyway.
Cool.
That's that. Do you have a quote for us today?
I do. I have a very dramatic quote for you.
Ooh.
So, it's from Hamlet. And so it's, to be or not to be, that is the question. Whether it is nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles and by opposing end them. Okay, so there's more there too. But so it's kind of, I'm doing that quote because it's awesome and Hamlet's great. But because that was like a big part of my secondary school, was we had to... Everyone, you have to study a Shakespearean play and it cycles through. And so a big part of that was memorizing quotes that you could use in your essays in this big state exam that we do. So it's kind of funny, and I felt very dramatic as a 17-year-old being able to randomly quote Hamlet all over the place. But so it's because that's what we're kind of talking about today, is memorization, and memorization for exams, and whether there is merit in it, or what do we think about it? So anyway, it seemed relevant that I have these random, I didn't do that from memory, that would have been more impressive, but I do have all of these random things in my head that I have memorized throughout my life. So
Can I say, you didn't do it from memorization, but you knew it, and you double checked it by looking it up?
Yeah, so it's in there somewhere, for sure.
So, if you hadn't had it memorized, you might not have thought to check it. I don't know.
Can I ask you, before we start talking,
okay,
right, what was your experience of undergraduate exams? Because in my day, which is some time ago, we were never given equations. I know. So we had to remember, a part of...
Every equation you had to memorize.
The grade was having, you remembered the equation, which was great for me because I was good at it. And it was a number of points you got for the exam was remembering the correct equation.
Was part of your exam write out the equations, or was it just as part of solving this problem you were going to need the equation, and so...
It wasn't explicitly what's the equation, but it was that was the starting points you got on a test. You know what I mean? If you had the right equation. Yeah. That was part of it. So,
my undergrad experience was more most classes that involved equations, or calculations, usually I was allowed to bring some kind of note card that I wrote whatever I wanted on. Sometimes there were also provided equation sheets that you got with the exam. I don't remember ever being told you must memorize an equation. I don't think. So I had a very different experience, I guess.
Okay, yeah. Because I feel like it's just changed over time. And even when I started teaching, I felt like more students were like, do we have to memorize stuff? And then at the end of it, it was just assumed that you weren't memorizing. You know what I mean? It just seems like it's an ingrained thing now. So, I don't know if that's true. Okay. But tell me, what is working for you in terms of...
I am... Let's see. So what's working for me, I guess I'm basing it off of my undergraduate experience. I have... For most exams that I have, so the classes I'm teaching involve a lot of calculations. They don't involve a ton of equations. They involve a few equations, but they really involve knowing how to solve certain types of problems, which sometimes involves equations and other times just involves a process and an understanding of the system and how to mathematically use your understanding of the system to calculate something. So anyway, I have been following my experience as an undergrad. And I usually, in most of my classes, allow the students to bring a note card where they wrote whatever they wanted on it. I say they can write out example problems fully written out. They can write out equations. They can whatever they want to write. Totally up to them. But they only have this 1 3x5 note card. They are not allowed magnification. They have to use their own handwriting. And I really like that.
How involved would that be? You can just totally imagine some student. You're like, dude, just study for the test. Don't devise the most amazing magnification system. Sorry, go ahead.
So I really like the note card. I feel like it encourages studying because they need to make their note card. So they have to say, well, what should I put on my note card? And then hopefully they're practicing problems while figuring out what they need to put on their note card, I would hope. I also feel like if they are, maybe they're making several versions of the note card to try to fit everything on there. So hopefully they're writing down exactly what they think they're going to forget a whole bunch of times. Maybe it actually does end up in their head because they're trying to do that, or maybe the act of writing it down helps. So I like that attribute of the note cards. And I feel like it doesn't have to be either or. You either have a note card that you write down whatever you want, or you have a equation sheet that's provided with the exam. I feel like there might be times when both is appropriate, or either or neither. Yeah. So, yes. So I like that, and that's working for me. And I do like, I feel like it boosts their confidence a little bit to say you can write whatever you want. And so if you're worried about forgetting that, write it on your note card. And like I say, I feel like I hope that it encourages the kind of studying that I want them to be doing, which is thinking about how you do these problems and what information it might be helpful for them to have to do those problems involves thinking about doing those problems, which is what they should be doing. So I don't know, that's working for me.
Yeah, I love that. And I think, like, when I was thinking about what's working for me, I was sort of thinking about like the practicalities and then also just my internal soul searching. So I think like I've been on kind of a journey with memorization where at first I was like, memorization is terrible and that's an awful way to learn. And I've really come, maybe not full circle, but somewhere around the circle to like, I think memorization has its place in a way. And I don't, maybe this is more of a working on, I don't quite know how to encourage it without necessarily penalizing people about it. Do you know what I mean? Because I do think, so I just had this experience of grading this huge amount of exams. And it's the first exam I realised I've ever done where they were given a printed sheet of equations.
Okay.
Do you know what I mean? And it was wild, like absolutely wild, what students did with those equations that clearly demonstrated they maybe had never interacted with that equation before. That, you know what I mean? And so it was like, and it's kind of tedious to get like, but just really like, anyone who's taken a physics class probably knows that there's a lot of repeating symbols.
Sure.
But with a bit of context, you know which one is which, but it was not. So I previously have done what you described, where I get them to make an equation sheet, but I've kind of limited to 2 equations, but I really like what you do. And I think maybe I told you this before. I had a student once like do all of the equations, but like in the shape of a dinosaur. They did like a Diplodocus the first time, and then each exam they would do a different dinosaur, but like write all the, I can't even describe it because it was so, I think I have a photo of it somewhere. I'll have to dig it out because it was the best thing I've ever seen and it made me laugh so much. But I really think you're right. Like I think for memorization, I think I don't like providing the equations. And that feels like a degree of disconnect. And I think the act of preparing the equation sheet, and sure, like I had so many students who literally just went through the book and got every equation that's in a highlighted box, fine. But like so many students put a lot of time and effort into it. And I would even, like I used to kind of like probably unnecessarily frighten them and say, like if you have to hand in the equation sheet, and so if there's anything untoward on there that wasn't supposed to be there. So I was like, if you bring it to the class before the exam, I'll check it and make sure. And that actually generated like a lot of people working together on making their equation sheets in that class, and because they wanted to have it looked at. Do you know what I mean? So that was good. And then just having it arranged even by different topics, because that was something I think when I graded this exam, I don't think students were able to necessarily group which section of the course it was from. Do you know what I mean? So even, I think that's really important to have them do it themselves. So I do think, like you're saying, I think like it's actually a study aid to do that, and it actually promotes, So I think there is that. And then I do think, like, ideally if you just do something enough times,
yes,
you do remember it.
Exactly. I agree completely.
I think like I'm really drawn to, I think I told you this before, where I listened to an interview. I don't have any details about it except that it was in my car. That's the only information. I don't even know what radio station it was.
So I can picture the scene.
Yeah, okay. You can get the visualization, but no other information or validation. But it was someone interviewing someone who was like, had been like acknowledged as an excellent math teacher. And this person was saying they really do believe in memorization, and it's really important to teach like conceptual understanding. But at a certain point, you need that vocabulary, just like for learning a language. And you can't always sit down and figure out, like, what is 3 times 4? Like, you actually just need to have it at the tip of your tongue. And so I do actually think there's merit in memorizing things. And and maybe this is projecting my own experience, but like, I think you have to engage with something to a certain degree to remember an equation. Like, I don't, maybe that's, but like, you're not just remembering a string of letters. Like, you have to remember something about, like, pressure is equal to, like, it's related to density. You know what I mean? Or there's something you have to use about the actual thing. So I think the thing I think I'm saying is working for me is I think I've come around to really believing that memorization is not only not a bad thing, it might actually be a good thing to do, to even free up your brain to do other stuff and sort of, you know, but I don't, well, I'll talk about that in a minute. But yeah, that's where I'm
That's
at.
Fascinating. I have so many thoughts. I mean,
okay, tell me.
The first thought I have is I agree. Like, I keep coming up with this example of density. Like, to understand the concept of density, I feel like you have to know that density is mass over volume. And if you don't know that, like, you could have gotten there by memorizing it. You could have gotten there by doing a lot of working with that concept. But if you have to look that up, then that means you don't understand what density is, you know? And even if you just sat down and memorized density is mass over volume and you memorized it and you haven't really thought about it, having that accessible feels to me like you still could pretty easily figure out what density is. I don't know. I guess I feel like that is, I don't know. I agree with you in the value of having things readily accessible in your mind. Yeah, that's really interesting. So do you think, let's go back to, you gave this exam, the students had equation sheet provided, and you felt like some of them had never really interacted with the equations before the exam, which obviously that's the problem. I mean, regardless of whether they're going to have an exam provided equation sheet or not, you would hope that they would have spent a lot of time with these equations doing those kind of problems before the exam, regardless of how you've set up the exam. But do you think, it seems to me like the issue is, do you think that by telling them that you're providing an equation sheet, you are encouraging them to spend less time with the equations? Because that would be potentially a problem.
That's a really good question. Because I wonder, that's what I'm assuming, right? And I'm assuming that they just came in and were like, well, I'll figure it out on the day and hope for the best. But maybe those students were never going to learn it off, even if, you know what I mean? So maybe that's, that's the thing. Maybe I'm not even talking about memorization, and maybe I'm talking about preparing the note card. Because again, like, it's sort of tedious with the details, but like, the letter P stands for pressure, but it also stands for momentum. And it's quite clear from the equations which one is, you know what I mean? But it wasn't. They were using them interchangeably or, you know, that I mean,
that sounds like, obviously those students weren't prepared and weren't familiar with the equations, weren't familiar with the concepts. The question is just, how do we help them? How do we encourage them to be prepared? And maybe it's by not providing the equations or getting them to do, but maybe it's just, I mean, I'm sure you had homework assignments where they were interacting, hopefully, with those equations.
That's such a good question, because it's hard to know, right? Like, and is it, you know, because it can be like a genuine security blanket. And as someone who's a very anxious person, like, I could really, like, absolutely know what density is and still want to see it written down and be like,
it's nice to just be like, oh, yeah, for sure, Like when I add 3 + 2 on the calculator, like, why do I do that? Like, I do know the just
answer.
Just double checking.
Yeah, I know. So, like, but it's, I guess the thing is, maybe those extreme cases are going to be extreme no matter what. But I think there is even something in, like, I get it. Like, I get that the point was, what we really want to find out is, can you solve the problems? Like, we're not looking at whether you can just memorize stuff. But then I think there's something that got thrown out with that as well. Yeah. You know, and
I know what you mean.
And I think the assumption there is that anyone can memorize things without having a connection with it, which is not true, right? Like, you can't memorize, like, even the Hamlet quotes or whatever, like, you can't memorize a string of words without associating some meaning. And there's lots of things I know I memorized by making up garbage meanings that didn't have any, you know what I mean? But, like, still, you have to do some level of engagement with something to memorize it. So,
yeah. I mean, I remember I learned the second paragraph of the Declaration of Independence because my mom said that was really important, and I still know it. And so if I'm ever interested in thinking about any of those concepts, it's readily accessible in my brain. And similarly, I remember I made up a garbage, I wouldn't call it garbage, but I made up a mnemonic to remember the amendments to the Constitution. And I mean, if I can remember them through this mnemonic that I made up, that still means that I know them.
Right. And I think, again, it reminds me a little bit of the sage on the stage thing we talked about, where it's like, there's so much, it is really important. Like, someone memorizing an essay is not really necessarily demonstrating what you hope they're demonstrating, you know, if they regurgitate that. But then I don't think it needs to swing all the way away from, you know what I mean? So I think, yeah.
And I 100% agree with you. I think you said this, that hopefully, in terms of solving problems and being comfortable with these equations or this type of problem or this type of calculation, I completely hope that the students they do enough problems, they do enough interactions with this, they spend enough time with it that it is memorized. But they got it, hopefully, through doing all these, you know, they could glance at the equation sheet if there's an equation sheet to double check, but they've already memorized it by going through the process a bunch of times. I would hope that would be the optimal scenario, I think.
Yeah, totally.
So, I'm working on...
Oh, sorry, yes.
Oh, no, go ahead.
No, you go, yeah.
Okay, so I was talking with Ralph about this before, you know, in preparation for this episode, and I was totally 100% on board with my note card thing, because, you know, where the students write their own note cards. I was sold. That was what I was doing. But chatting with Ralph about it, it was kind of blowing my mind that the note card I see as a tool to encourage studying beforehand. But could a really well-crafted equation sheet that I provide with the exam be a resource that they take with them afterwards and potentially use in the future? And the benefits would be they know it's all correct because I provided it, you know, and maybe they didn't, if they handwrote it, maybe they missed a positive or minus.
Oh, and I've had that happen.
Sure,
yeah, for sure.
So they have this equation sheet. They know it's correct. They're used to using it because they've been using it on my exams. They can take that with them. And that actually sounds kind of meaningful in terms of setting them up to use those skills going forward. If they do, hopefully they're really familiar with the equations, but they can just glance at it to verify, oh yeah, that is the equation I thought it was, or let me just double check if that was a plus or minus or whatever. So it's kind of making me question whether maybe I do want an equation sheet that I provide for that kind of thing. And I think one of the reasons I was really against equation sheets is that I felt like maybe I'd be doing half the problem for them. I would only give them 4 equations, and they'd be like, well, if those are the 4 equation options, then I'm going to pick the one that's obviously the right one for this problem, and I'm kind of just turning it into an algebra problem. But that would be a mistake in how I made the equation sheet. I could make a much bigger equation sheet that has all the equations we're going to use the whole semester, and they do have to think to choose the right one, and then they have this reference going forward. So, I don't know, if I've managed making a good equation sheet, I suppose it could be, like, one of the things is I feel like it should be testing, can they solve these problems in real life? And in real life, they do have the textbook, but the problem is there's a million equations in the textbook. So, I want them to be able to find the equation that they need to use and be able to use it appropriately. So if I give them something like an equation sheet where they still have to find the right equation, I feel like it is kind of a real-life scenario where you can look up and double-check that. I don't know. So that's some thoughts.
See, I like this, right? And the thing that I'm kind of feeling with this is, I wonder then, could you like really integrate it with, what do you call it again when you have like the worksheet days? We're not calling it worksheet days anymore.
Oh, I don't know what we're calling it, but we're having an in-class activity where they work in groups doing problems. Yeah, okay. Mm-hmm.
So like, what if there was something like you even had some of the equation sheets like laminated or something, and they were like 1 per group, and it was something that they engaged with all the time.
All the time.
This is our equation sheet.
That's a fun idea.
That would be kind of cool. I think the thing with this one maybe was like they hadn't, I mean, I think it had been provided to them, but they weren't using it before. But I wonder if it was really like, this is our go-to and we always look at this, then it would be like then the exam would really be a reflection of like what the normal problem-solving process was like. Do you know what I mean?
That makes sense. That makes sense.
So like if there was a way of, again, like making sure they're really engaged with that all the way up to the exam, so it's not just like, oh, this is the first time I'm seeing this, and then I'm, scrambling for the equation or whatever.
Yeah.
But I think you're right. Now I've completely...
I know. I feel like preparing for this episode, I've gone 180 multiple times, and now I'm just interested in all the concepts.
And it's funny too, because then even, like, I don't know if this is true in chemistry, but there's some fundamental equations, like, I do think you should know. And then there is other stuff at a certain point that it's just like, okay, look, you're going to use this, like, once in a blue moon. You know what I mean? Like, you don't need to memorize this. Like, it's fine. But, like, you need to know
there's more complicated equations where I really want you to be able to identify that this is the right equation for this situation, but I don't really care that you have the equation memorized. You should definitely go look it up and double check whenever you use it.
Totally.
So that's a different kind of equation than one that you're using every time, like density. You should definitely know density. But hopefully you will. Like, if you don't know density, that means you haven't spent much time with this content, and hopefully it'll show up somewhere in the exam. Right. I don't know. So that's interesting. So what are you working on?
Yeah, I want to hear back about how this goes, because I'm even thinking you could just have it be part of the worksheet then, like, or the packet. Totally. Like, it's like and it's always the same thing. That would be super interesting.
I mean, one thing it makes me think of is, so in quantitative analysis, we're doing a lot of looking at chemical reactions, like. We look up a lot of constants in the back of the book, I guess is what I'm saying. So there's a lot of equilibrium constant values that you look up in the back of the book. Like, there's a equilibrium constant for every single acid. And it's like, how much like an acid does this particular acid behave versus this one? And they have different amounts of how acidic they are. And you're not going to memorize those. There are constants for every single acid out there. So you look it up in a table. And so I do always provide those with the exams. And now it's a whole table. You have to find the correct acid and know the correct constant you want to look up and find it. But it feels to me like it could, if I threw enough equations on there that they also had to go find it and know that they were looking for it, I wouldn't be giving away the whole problem. Yeah. They still have to know, because when you encounter a buffer problem, I want them to say, oh, this is a buffer problem. I need the Henderson-Hasselbalch equation, and here's how you use it. So as long as they know, oh, I need to go look up the Henderson-Hasselbalch equation, I think I'd be okay with them going and looking it up,
Yeah, totally.
Yeah. So anyway.
This is interesting. Yeah.
Yeah. Anyway, what are you working on?
I think what I'm working on then is, like... I think my working was kind of, I have come to terms with the fact that I think memorization is not a bad thing. But then I'm working on wondering, like, am I projecting my experience? Because it has depleted with age, but I've always found, like, memorizing stuff really easy. So I was like, sweet, give me the points for remembering this equation. And, like, that was, like, part of the way I engage with things. And I guess that's the thing I'm wondering is, like, is that just my way of learning? And should I, like, find out about other people's... Like, I guess the thing is, I don't think I would ever want to be in a situation, and neither of us have said this, right, that we're, like, going to take away any supports, right? Because I don't want to penalize people, because if people really can solve problems but they forget the plus or the minus or whatever, like, you don't really want to be, taking points away from people. So I think maybe having them prepare stuff or engaging with the equation sheet beforehand or all of those things is ways of doing it. But yeah, so I think I should try and find out about other people's ways of learning. And, like, yeah, so I think that, and then the other thing I guess I would ask our larger audience about different types of memorization. Because for us, like, we're talking about equations, but, like, is there things like how do people feel about memorizing quotes? Or, like, obviously in history, memorizing dates, like all of those things, like, how does that sort of tie in? And then, I mean, obviously when you're learning a language, there's just, like, a certain baseline vocabulary you need to know to be able to communicate and stuff. So yeah, just memorization in general. But yeah, I think I would sort of, before I made any changes or did anything, I think I would want to know more about other people's learning styles and how that can be an issue for memorization or whatever.
Man, I totally agree. That's really interesting. I mean, the first thing that comes to mind, I also want to throw in biology, I think of as a high memorization thing. You need to know the scientific names and all the different types of plants. And that seems like you just have to memorize it. And that's a part of knowing it. And there's concepts that you can learn around the memorizing, but you have to have the basic understanding that I think probably comes from memorizing to get the broader picture from there. So yeah, I'd be really interested to hear from our listeners about different disciplines and how memorizing fits in. And then your thought, Ruth. Oh, sorry, go ahead.
No, you go.
Your thought about what about different learning styles? And I think that's a really good point. And we've talked a lot on this podcast about we want to teach to a variety of learning styles so that a variety of students can really, go really well in our class. But it makes me think about, like you're saying, I think maybe you mentioned throwing the baby out with the bathwater. We don't want to throw out, and I think you were saying, there's probably some good things in memorization. We don't want to throw them away with the bad things in memorization. Here, I feel like a similar thing. If memorizing worked really well for you, there's probably some other people it works really well for.
Right.
There's probably some other people who maybe it doesn't automatically work well for, but they would still benefit from it. So that's not to say we should only do memorization necessarily, but I wouldn't throw it out. I mean, it works for you. That sounds great. You should definitely. I feel like that means...
Right, but then here's something wild, right? Like, should you go completely just wild and have like I'm thinking of like a spelling test from back in primary school, but we're just going to do a quick equation test at the beginning of class, and you need to know this one equation by next class. And I mean, and
you could totally
even saying that feels really weird to me, and like I feel uncomfortable about it. But then, so I guess I think I want to ruminate more on how much I think it is important and how much I think it does actually benefit people. Do you know what I mean? And because I feel
and it all depends. Go ahead.
No, you go.
It all depends on what we're trying to get them to learn. And like you say, if we are, if it does seem like this is an equation that they really should know, I have no problem with having a little quiz.
Right.
Hey, you're all going to need to write down this equation. And then, hopefully they've gotten something out of the interaction that they did with that equation to memorize it. That would be fine with me. Or there's some equations where, they just need to be able to use it and recognize that this is the right time to use it. And so we don't need to have a memorized day. It's all about what we're trying to teach, what we want them to be able to do, what we want them to get out of it, I feel like,
Here, dude, I have a question.
What's your question?
Is there still in chemistry, do people still have to learn the periodic table? Is that a thing?
What do you mean by learn the periodic table?
Did people used to have to do that? Like learn, I feel like I had to learn like 2 rows or 3 rows, or there's some, I can't remember, but is that...
We definitely learn, I don't think, in my experience, I haven't seen people be tested like, what's the atomic mass of whatever.
Right.
But we do definitely talk about periodic trends. So you do have to remember that as you go up and to the right on the periodic table, electronegativity increases or something like that. And then you can think about why, So you can memorize that, but it's also connected to how the atoms are shaped and where the electrons are and chemical reactivity, and so it all fits together. This is a great example of, I feel like it would be useful to just memorize electronegativity increases as you go up and to the right on the periodic table, because it fits with all these actual real things that are happening on the periodic table, and hopefully you also understand those things. But you can kind of get to a lot of them. You can get to it either way. You can get to it by saying, oh, there's more electrons in the outer shell, yada, yada. Or you can get to it by saying, I remember this. So why is that true? Let me think through the atoms. Okay, yes, now I remember why that's true. So I feel like it all fits together. I don't know. So, but I don't remember, I have not been in a class where we needed to like fill in the first 3 rows of the periodic table or anything like that.
Okay.
But you do need to be able to use the periodic table to say, oh, well, this element, because it's in this spot of the periodic table, has this many free electrons in this shell and this many, whatever it is, and therefore I predict that it would react in this way.
I think what I'm kind of getting called to with all of this is just really making sure that the students are engaging with what you hope they're engaging with.
Yes.
And so I think there is a separate question of like, memorization just as a concept, and is it useful for learning? And I think I'm leaning towards yes. But then the real thing for exams is just so they're not rocking up. Like you're even saying, like they're not rocking up being like, well, she's going to give us the periodic table. I'm never going to interact with it before the exam. Like that's
right.
But that's obviously you structure things so that's not happening. So,
right.
Yeah.
I mean, I do provide the periodic table, but you have to know how to use it to be able to answer the questions. And it's certainly not. And
I think that's the thing. Maybe I did not convey to these students, like, sure, the equations are going to be here, but you cannot have never looked at them before and hope for the best. You know what I mean? So, yeah.
Yeah.
Okay. This is cool. Thank you.
This is really interesting. Thanks, Ruth.
Thanks so much for joining us on the Professor Podcast with Ruth and Claire. We're delighted to have you as a listener, and we would love to hear from you. And if you want to email us, our address is contactprofessorpodcast@gmail.com. We'd love to hear any of your suggestions for future shows or professor quotes that you might want to share with us, or even just things that have come up for you when you were listening to previous episodes. And if you've been enjoying the podcast, we would love if you would spread the word. So the best way to spread word is by telling people you know if you think they should listen to it, or you can leave us a review wherever you listen to your podcasts. Thanks so much for joining us, and we'll see you next time.